Good morning all. Today we are going to see the Decorator Design Pattern, which is a structural pattern. So here main intent of the Decorator Design Pattern is to attach additional responsibilities to an object dynamically, and Decorator provides a flexible alternative to subclassing for extending functionality, and this decorator lets you to attach new behaviors to objects by placing these objects inside a special wrapper objects that contain the behavior. And this decorator is also known as wrapper. Coming to the motivation, sometimes we want to add some responsibilities to individual objects, not to an entire class. So here imagine that you're working on a notification library which lets other programs notify the users about important events. The initial version of the library was based on the notifier class that had only a few fields, a constructor and a single send method. The method could accept a message argument from the client and send the message to the list of emails that were passed to the notifier via its constructor. And here, the third party app, which acted as a client, was supposed to create and configure the notifier object once and then use it each time something important happened. So, at some point, you realize that users of the library expect more than just email notifications. So many of them would like to receive some SMSs about critical issues. Others would like to be notified on Facebook. And of course, the corporate users would like to get Slack notifications. So how hard it can be? You extended the notifier class and put additional notification methods into new subclasses. Now the client was supposed to initiate the desired notification class and use it for all further notifications. But then somehow visibly asked you, why can't you see several notification types at once? If you are tried to address this particular problem by creating special subclasses which combined several notification methods within one class. However, it quickly became apparent that this approach would both the code immensely, not only the library code but the client code as well. So here in the figures you can find that the notification notifier, so here the SMS notifier, Facebook notifier and Slack notifier. Here we are going to have number of subclasses or number of instances which are created by the notifier. So you have to find some other way to structure notification classes so that the number won't accidentally break some genuineness record. So what is the solution for this? So here extending a class is the first thing that comes to mind when you need to alter an object's behavior. However, inheritance has several serious caveats that you need to be aware of. So here one of the ways to overcome these caveats is by using aggregation or composition instead of inheritance. So here we are going to use the inheritance instead of aggregation or composition. So let's leave a simple email notification behavior inside the base notifier class, but turn all other notification methods into decorators. So from the figure, you can see that a client code would need to wrap a basic notifier object into a set of decorators that match the client's preferences. The resulting objects will be structured as a stack. We could apply the same approach to other behaviors such as formatting messages or composing the recipient list. The client can decorate the object with any custom decorators as long as they follow the same interface as the others. So here the scroll decorator and border decorator classes are subclasses of decorator. An abstract class for visual components that decorate other visual components. Visual component is an abstract class for visual object. It defines the drawing and event handling interfaces. So decorator subclasses are free to add for specific functionality. So here the client core would need to wrap a basic notifier object into a set of decorators that match the client's preference. The resulting object will be structured as a stack. Coming to the second modification, for example, suppose we have a text view object that displays text in a window. Text view has no scroll bars by default because we might not always need them. When we need, we can use scroll decorator. Suppose we want to add some thick black border around the text view. So here we can use border decorator to add this. Simply compose the decorators with the text view to produce the desired result. So see here in the figure, visual component, a text view as well as a decorator. So whenever we want a scroll decorator, whenever we want a scroll bar, we are going to use scroll decorator. Whenever we want to draw border, we are going to use border decorator. And coming to the applicability, here the design patterns can be used whenever we want to add some responsibilities to individual objects dynamically and transparently. That means whenever we want to add some responsibilities, but these should not affect the other object. And here this can also use the pattern when we want to withdraw the responsibilities. Suppose whenever we want to withdraw the responsibilities of the objects, then also we are going to use this decorator pattern. So use the pattern when it is awkward or not possible to extend an object's behavior using inheritance. So coming to the structure. So here we are going to see the structure. So in this the participants are component, concrete component, decorator and concrete decorator. So here the component defines the interface for objects that can have responsibilities added to them dynamically. And here the concrete component defines the object to which these additional responsibilities can be attached. And here the decorator maintains a reference to a component object and defines an interface that conforms to component's interface. Coming to the concrete decorator, this adds responsibilities to the component. Coming to the collaborations, so here the decorator forwards request to its component object. So it may optionally perform additional operations before and after forwarding the request. Going to the consequences, what are the pros and cons of decorator design pattern? So here coming to the advantages, you can add an object's behavior without making a new subclass. So by using this pattern, we can add or we can extend an object's behavior without making a new subclass. And here by using this pattern, we can add or remove responsibilities from an object at runtime. And this can be used whenever we want to combine several behaviors by wrapping an object into multiple decorators. And here we can divide a monolithic class that implements many possible variants of behavior into several smaller classes. And coming to the limitations, it's hard to remove a specific wrapper from the wrappers stack, and it is very hard to implement a decorator in such a way that its behavior does not depend on the order of the decorator's stack. And here the initial configuration code of layers might look pretty ugly. Coming to the implementation, so here we have several steps for implementation. So the first step is make sure that your business domain can be represented as a primary component with multiple optional layers. And next we are going to figure out what are the methods which are common to both primary component and optional layers. And here we are going to create a component interface and what are the different methods which are there. And next we are going to create a concrete component class and define the base behavior. Next, we are going to create the base decorator class, and this should have a field for storing reference to a wrapped object. And after that, you are going to make sure all classes implement component interface. And next step is create the concrete decorators by extending them for a base decorator. A concrete decorator must execute its behavior before or after the call to the parent method. The client code must be responsible for creating decorators and composing them in the way the client needs. Coming to the non-users, so many object-oriented user interface toolkits use decorators to add graphical embellishments to widgets. So here we are going to see some known users which are going to use these decorator patterns. Interviews, ET++ and ObjectWorks Smalltalk class library is going to use this pattern. And more exotic applications of decorator are the debugging glyph from interviews and the passivity wrapper from Park Place Smalltalk. And coming to the related patterns, so here adapter, composite and strategy are the related patterns to the decorator. So here the adapter changes the interface of an existing object while the decorator enhances an object without changing its interfaces. And composite and decorator will have the same structure diagrams, and decorator lets you change the skin of the object while strategy lets you change the guts. So here we have seen the entire information about the decorator design pattern. So thank you for your attention.